Hello and welcome to the Unit 10 Section 1 video on displaying data. So this unit's all going to be about a little bit of statistics, okay? So we are branching off of geometry and kind of getting into kind of our own topic here to finish off the geometry course. And we're going to start by talking about data distributions. A measure of central tendency describes the center of a set of data. Measures of central tendency include the mean, median, and mode. So the mean is probably the one that you are most familiar with. The mean is the average of the data values, or the sum of the values in the set divided by the number of values. Okay? You've probably worked with averages quite a bit. The mean is another word for average. The median is the middle value when the values are in numerical order, or the mean of the two middle numbers if there are an even number of values. Okay? So if there are an odd number of values, you just pick the middle one. If there is an even number of values, when you split it up, well, your middle ends up between two values. So you're just going to take those middle two values and take the average or the mean of those two numbers. The mode is the value or values that occur most often. A data set may have one mode or more than one mode. If no value occurs more often than another, then the data set has no mode. Now, another term to keep in mind is the range. The range of a set of data is the difference between the greatest and the least values of the set. The range is one measure of the spread of a data set. So to find the range, you take the biggest number, subtract the smallest number, and that is your range. So let's find these values in example 1. The numbers of hours Isaac did homework on 6 days are given here. We want to find the mean, median, mode, and range of the data set. So first, we're going to take the data set and we're going to arrange it from the smallest value to the biggest value. So we've got 3, we've got 2 4s, so we're going to put 4 and 4. We've got a 5, we have a 6, and we have an 8. So we have 6 values in total. So to find the mean, we're just going to take the average of them. So we take all of our values and we add them up, and then we divide by the number of values we have, in this case 6. And so that gives us 30 on the top divided by 6, so our mean is 5. Now the median is going to be the middle, okay? So we have 3, 4, 4, and then the middle occurs here. We have 5, 6, and 8 on the other side. So since we have an even number of values, we have to take the average of the two that are on either side of the middle. So we're going to take the average of 4 and 5, and so the median is 4.5. The mode is the value that occurs most often. We have 2 4s here, so our mode is 4. And then the range is our largest value, which is 8, minus our smallest value, 3. So our range is 5. Now you measure of central tendency describes how data cluster around one value. Another way to describe a data set is by its spread, how the data values are spread out from the center. So we talked about range being one way to describe that. Quartiles divide a data set into 4 equal parts. Each quartile contains 1/4 of the values in the set. The first, or lower quartile, is the median of the lower half of the data set. The second quartile is the median of the data set, and the third, or upper quartile, is the median of the upper half of the data set. So in this figure, we have our data set, and the median of our bottom half is 3. So our first quartile is 3. The median of our upper data set is 7. So our third quartile is 7. The median of our data set is 5. So that's our second quartile. The interquartile range of a data set is the difference between the third and first quartiles. So you're going to take 7 minus 3, and that gives you your interquartile range. So in this case, it's 4. Now the range of the entire data set is our 9 minus 1, which gives us 8. Now the interquartile range represents the range of the middle half of the data. So all of those ideas that we just talked about with the quartiles, we can create a visual that helps us determine what this is going to look like, and that is called a box and whisker plot. So a box and whisker plot, or box plot for short, can be used to show how the values in a data set are distributed. You need the 5 values to make a box and whisker plot: the minimum or the least value, the first quartile, the median, the third quartile, and the maximum or greatest value. So in example 2, we are going to create a box plot. So the first thing you need to do is take all your data values. The numbers of runs scored by a softball team in 20 games are given here, and we're going to use the data to make a box and whisker plot. You want to take all of this data and order it from smallest to largest value. So I'm going to start by doing that here. So this will take a little bit of time, but we have 2, 3, 3, 3, 4, 4, 4, 5, 7, 7, 8, 8, 9, 9, 10, 10, 11, 12, 12, and 14. Those are our 20 data sets, okay? 20 pieces of data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Not a bad idea to count the number of pieces of data that you have to make sure that you didn't leave anything out or accidentally put something twice. Now we're going to identify the 10 needed values. So we know that 2 is the minimum. Okay, so this is our minimum. And we know that 14 is our max. Okay, those two are the easiest to figure out. Now we know we have 10 pieces of data. So let's find out what our median is. That's our second quartile. So our median is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our median is going to occur right here. So our quartile 2, or our median, is going to be 7.5. Now we are going to take the bottom half and split that into 2. 1, 2, 3, 4, 5. So that occurs here. This is where our first quartile is, and that is going to be 4. Since it's between two 4s, average of 4 plus 4 divided by 2, that's going to be 4. Then we do our upper half. 1, 2, 3, 4, 5. We split our data here. 5 here, 5 here. And this quartile is going to be 10. And now we have the 5 pieces of information we need to create our box plot. So you're going to draw a number line, which is provided for you there, and plot a point above each of the 5 values that we just determined. So we have 2, we have 4, we have 7.5, which would go about here, we have 10, and we have our maximum, which is 14. So now what you're going to do is create a box from the first quartile to the third quartile. So the box is going to go about here. In fact, let me make it nice and neat since it's hard for me to draw on here. So you're going to draw a box like so. Okay? So now you're also going to draw a line going through the median. And then you're finally going to draw a line that extends from the first quartile to the min and from the third quartile to the max. And this is your box and whisker plot. You have the min here. You have the first quartile here. You have the second quartile here, which is your median. You have your third quartile here, and here is your max. Another way to display data is by making a histogram. The frequency of a data value is the number of times it occurs. A frequency table shows the frequency of each data value. If the data is divided into intervals, the table shows the frequency of each interval. So in this example, we're going to take this data and we're going to identify the least and the greatest values, divide the data into equal intervals, and then list the intervals in the first column of the table. And then we're going to count the number of data values in each interval and list the count in the last column, and then we'll give the table a title, which is already done for you here. So if you look at this data, the lowest value we have is 68. The highest value we have in this is 82. So given the least and the greatest value, we're going to do this on an interval of 3. So our scores are going to be 68 to 70, 71 to 73, 74 to 76, 77 to 79, and then 80 to 82. So the frequency that we have this first score is 3. You just count up how many you have that are between 68 and 70. Then you count up the next one. You have 4. Then you have 6. Then you have 2. And then you have 1. Now the best thing to do after you've done that is to determine if you have all your data. Add up all your numbers of your frequency and see if that's the same as the number of pieces of data you have, just to make sure you didn't leave anything out or accidentally count something twice. Now, it's all well and good to have this in a table, but it's a lot of times it's easier to see what's happening when it's visual. So a histogram is a bar graph used to display the frequency of data divided into equal intervals. The bars must be of equal width and should touch, but not overlap. So in example 4 here, we're going to use the frequency table that we just created in example 3. So use that as reference, and we are going to make the histogram. So the first step is to use the scale and interval from the frequency table. So the highest frequency we have is 6. So we are going to make that the top of our graph here. The second step is to draw a bar for the number of scores in each interval. All bars should be the same width. The bar should touch but not overlap. And then you can title the graph and label the horizontal and vertical scales. So what we're going to do here is we are going to create our bars on this graph. So the frequency of our scores of 68 to 70, that is 3. So we are going to draw our bar here. And then for the next one, we have 4. So we're going to draw our bar there. For the next one, we have 6. So we draw our bar here, going to 6. For 77 to 79, we have 2. So we're going to draw our bar going here. And for 80 to 82, we have 1. So we're just going to draw 1 bar going up there. And we're going to have them touch, about be the same width. And then, of course, you can shade these in if you'd like. I did not shade these, but shading, not a bad idea. All right, another way to display data is by doing a dot plot. Okay, so a dot plot is a data representation that uses a number line and X's, dots, or other symbols to show frequency. Dot plots are sometimes called line plots. So here we are given a table showing the time spent studying for juniors and seniors in a math class. So we're going to find the least and the greatest values in each data set, then use these values to draw a number line for each graph. For each student, place a dot above the number line for the number of minutes he or she spends studying. So the number line is already given for you. We're just going to fill in the dots. So if we're looking at juniors, we had 2 juniors spend 5 minutes. So you're going to put 2 dots. Then for 10 minutes, we had 1. 15 minutes, we had 3. And we're going to make these dots go up at the same amount. See how everything lines up. For 20 minutes, we had 4, so you're going to do 4 dots. For 25 minutes, we had 5, so we do 5 dots. We also had 5 at 30 minutes. Then we had 35 minutes, we had 4, so we'll do 4 dots. We also had 3 at 40 minutes, so we do 3 dots, and then 2 at 45 minutes. For seniors, we're going to do the same thing. We had 1 at 10 minutes, we had 2 at 15, we had 3 at 20, we had 4 at 25, we had 4 at 30, we have 6 at 35, 2, 3, 4, 5, 6. We had 5 at 40, 1, 2, 3, 4, 5, and then we had 4 at 45, 1, 2, 3, 4. So it doesn't take very long to create, and you can see the distribution of the data. This section we're mainly focusing on creating these plots. In the next section we're going to talk a little bit more about how to interpret things in these types of plots and how to read these things. But just to kind of give you a little preview, if you look at the time spent studying by the juniors and the time spent studying by the seniors, you can see that the seniors tend to spend more time studying than the juniors. Now, of course, there's always exceptions here and there, but overall, the seniors are spending more time studying than the juniors because the data leans more toward those higher number of minutes for studying. But we'll talk more about how to read these things coming up in the next section.